Class, welcome to another exciting video in geometry. Today we are going to focus on the hypotenuse-leg theorem. Alright, and so we need to talk a little bit about what these words hypotenuse and leg mean. And so for that, what I'm going to do actually, guys, is I'm going to sketch this little picture over here of a right triangle. Okay, because we need to know some vocab here. When we have a right triangle, the side that's across from the right angle is always, 100% always, called the hypotenuse. And then the other two sides we call legs. And that's really important because we need to be able to recognize hypotenuses and legs to use the hypotenuse-leg theorem. Okay? So, here we go. If the hypotenuse and a leg of a right triangle are congruent to the hypotenuse and a leg of another right triangle, then the triangles are congruent. Alright? So, here's the deal. Very easy to see why we talk about H and L. The thing that we're going to do to kind of keep it consistent with our others, in that, like, we've had SAS, ASA, SSS, we've always used 3 letters. Well, we're going to do the same thing, and we're going to make a third letter for R. Alright? So we need the hypotenuse leg of a right triangle to be congruent to the hypotenuse and leg of another right triangle. Alright? So there's the 3 letters that we need. And so instead of writing HL, I'm going to say RHL. We always need a right triangle, right triangles. We need congruent hypotenuses, and we need congruent legs. Okay? And so now I also need to kind of debunk something that we've talked about previously. If we were using our old methods here, like if we didn't know about RHL and we looked at this, well, I would see 2 sides and an angle, and where's that angle? Oh, it's outside. It's not included. This would be that ASS situation. Alright? So this is a very special case. Special case of ASS that does work. Don't write that. Write RHL. Okay? So please make sure you know that this is a very special case of ASS. And again, normally we're not good with that. But because that angle is technically a right angle, which makes these triangles right triangles, well, then it kind of works. Alright? So here we go. We got to conclude. We got to say, well, if I go triangle ABC, right? I went from A to B to C. That means I would have to go from D, right, the unmarked, to E to the right to that. Okay, yeah, so D, E, F. All right? Cool. So here we go. I do want to do a couple of these just to kind of show you what I'm looking for here. So what do we notice? This is very similar to the page before, or the previous pages, but notice that we're now adding this HL, so that's another option. So please make sure you're on the lookout for that. And what do we see here? Ooh, here I have SAS, but here I have, oh, it turns out to be RHL. Do you guys see how, like, this is SAS, this is RHL? These aren't going to work, right? They don't match. They're not the same. So this one would still be kind of similar to what we've done before. That'd be a none. Now when we look at our next picture, we have 2 sets of angles and a side. The side is included, so this is just ASA. On our next one, what do we have? Oh, I gotta mark my reflexive property. Oh, so normally we would say 1 set of angles, 2 sets of sides, and the angles, normally we would say ASS. However, we now know that this one, because that angle is technically a right angle, we can use RHL, or HL. I'll take either. And lastly, let's see here. Oh, well, we have this. Oh, these are vertical, right? So if this is a right triangle or right angle, excuse me, then that's a right angle. And now we have what? Two angles and a side. The side is not between the two angles, so we would call this AS. All right? So that's kind of a brief rundown of why we have this, or of this new theorem, or new postulate, the RHL postulate. We now need to be able to use that. And so we're going to do one proof to kind of get into the swing of things, and maybe we can kind of, I don't know, hit the ground running in class tomorrow. So it starts the same. I'm going to mark up my given picture, or my given statements. I have PQ perpendicular to QR, so right angle. I have PS congruent to SR, so right angle. Cool. I also have QR is congruent to SR, so QR is congruent to SR. That's great. Lastly, I have something from the diagram, something from the picture that we have to recognize. And hopefully you guys can see that I have a shared side. So, normally I would say angles, sides, sides, or ASS, and we know that that's no good. However, what do we notice about this? We have right triangles, we have the legs, and we have the hypotenuse congruent to itself. So we can use RHL, congruent by RHL. Okay, again, this will just take some time to get used to it and add it to your repertoire of things that you're looking for. But I think you're going to be okay with some practice. So here we go. Again, I just go in order. So I'm going to start with my first given, and I'm going to say first... actually, so what do we get here? This is new, actually, because we haven't gone this route before. So when we have these perpendicular lines always form right angles. So I know that angle Q and angle S are right angles, and that's because of PQ is perpendicular to QR, and PS is congruent to SR. Did I say parallel? I meant perpendicular. PS is perpendicular to SR. All right. Well, that's not quite done, because if you remember, what did it say? It said that we needed right triangles. Right now we have right angles. So we actually need a brand new line to say that triangle QPR and triangle SPR are right triangles. But now that's what we needed, right? We needed right triangles, so I can put in my R. Second, QPR and SPR are right triangles, and that's because angle Q and angle S are right angles. Right? If a triangle has a right angle, then it has to be a right triangle. There's no choice but for that to happen. All right? Well, now we have our R. Now we can carry on and move on to our next given, or our next statement. So I have QR to SR. Okay, so third, I needed that. QR is congruent to SR, which is a side, or no, not bad, my bad, not a side. QR and SR are the, is it across from the right angle? No, it's next to it. So these are the legs. QR congruent to SR because it's given. Fourth, PR is congruent to PR, which is the hypotenuse. Because of why? Oh, the reflexive property. Because of the reflexive property. Reflexive if property. Okay? So now what do we notice? We needed an R, an H, and an L. We have an R, an H, and an L. We're done, guys. Well, sorry, almost done. We end with that therefore. Therefore, the triangles are congruent, so triangle QPR is congruent to triangle SPR. And what new postulate did we use? Well, we used RHL. So by RHL. And that is our first example of using the HL, or in our case, the RHL postulate. All right, so I know this is a little longer than I said it was going to be. I hope it's not too bad. I hope you're kind of catching the drift. Please just make sure that you're looking out for the situations when we have right angles, because it could be RHL and it might still be like SAS or something else. We'll show you that in class. Have a good one. Peace.